Why would one of the world's largest technology companies build a data center next to what amounts to its own private power system? In West Texas, Amazon is planning an enormous new data center campus on roughly 8,000 acres. Next to it, Pacifico Energy is developing GW Ranch, a private power system designed specifically for hyperscale data centers. The project has approval for as much as 7.65 gigawatts of natural gas generation, alongside planned battery storage and solar. And here's the unusual part. GW Ranch is being designed to operate independently from the Texas electricity grid. Pacifico says that can avoid lengthy grid interconnection delays while giving customers greater control over their electricity supply and expansion schedule. That raises a useful economic question. When does it stop making sense to rely entirely on shared infrastructure? Because for more than a century, electricity moved in exactly the opposite direction. In the earliest days of electrification, generating your own electricity wasn't unusual. Thomas Edison's first commercial electrical installation in New York began operating in 1881 at a printing company where a dynamo in the basement supplied a single customer. But Edison had a bigger idea. Instead of every building operating its own generator, one central station could distribute electricity to many customers. In 1882, Pearl Street Station began doing exactly that in Manhattan. Samuel Insull later pushed the model much further. Insull recognized that generating electricity required enormous investments in equipment and infrastructure. But as one system served more customers, those fixed costs could be spread across more electricity sales. Different customers also needed power at different times, allowing the same infrastructure to be used more efficiently. Economists call this economies of scale. Rather than every factory, office, and household maintaining its own generator, shared electrical systems could produce and distribute power more efficiently. That basic economic logic still helps explain the grid today, which makes West Texas particularly interesting. Amazon isn't abandoning the grid, and it isn't building GW Ranch's power plants itself. Pacifico is developing the generation, but the infrastructure is being built specifically around enormous data center demand. Because the calculation changes when one customer's needs become unusually large and urgent. Electricity generation, transmission, and grid connections cannot always expand on the same timetable as a data center. Texas is seeing that tension now. On August 3rd, Governor Greg Abbott ordered a pause on approvals for new data centers seeking grid connections while the state audits proposed projects and their potential effects. GW Ranch is different because its private grid design doesn't depend on an ERCOT connection. And that illustrates the principle. Shared infrastructure makes sense when specialization and economies of scale make it cheaper. But when requirements become unusually large, specialized, or time-sensitive, dedicated infrastructure can become attractive again. There's another reason this matters. Who pays? If enormous data centers require new generation, substations, or transmission infrastructure, existing customers understandably want to know whether those costs could eventually appear on their electricity bills. That concern is significant enough that companies and regulators are responding. In March, Amazon, Google, Meta, Microsoft, OpenAI, Oracle, and XI signed the Ratepayer Protection Pledge. They agreed to build, bring, or buy the new generation required for their data centers and cover necessary power delivery upgrades rather than passing those expenses onto households. But that doesn't prove data centers inevitably increase electricity prices. Research from the Electric Power Research Institute, examining 2015 through 2024, estimated that data centers actually modestly reduced average retail electricity rates over that period. More electricity sales can spread the grid's fixed costs across more customers. But researchers warned that future supply constraints could change that relationship. That's what makes GW Ranch worth watching. The shared grid became dominant because sharing infrastructure created enormous efficiencies. Now, massive computing facilities can create concentrated electricity demand large enough that dedicated power becomes attractive in particular locations. That doesn't mean private power is automatically better. GW Ranch plans to rely heavily on natural gas, creating environmental trade-offs of its own. And dedicated generation gives up some advantages that made shared infrastructure so powerful in the first place. But the larger lesson is simple. The boundary between what we share and what we build for ourselves isn't permanent. It depends on economics. More than a century ago, economies of scale helped move electricity from isolated generators toward enormous shared networks. Now, concentrated AI demand may push some projects partially in the other direction. Not because the grid has stopped being useful, because sometimes waiting for the shared system to expand becomes the bottleneck. If AI companies need enormous amounts of new electricity, should they be expected to bring more of that power themselves? Or is expanding the shared grid ultimately better for everyone? Let us know what you think below. If this breakdown was useful, hit like and subscribe to Synthetic Politics. We'll be back when there's more to report.